There's a liquid that costs $3 to make in your kitchen. One coat stops rust permanently on any metal surface: cars, truck frames, axe heads, cast iron, fence posts, trailer hitches. It converts orange corrosion into a black protective armor that fuses with the steel itself. No sanding, no expensive primers, no body shop. Roman shipbuilders used this compound to protect entire fleets for decades. Military engineers depended on it through 2 world wars. And then the automotive industry quietly buried it. They did not stop using it because it failed. They stopped teaching it because it worked too well. A $3 bottle that eliminates rust forever cannot sell replacement quarter panels. And what cannot sell replacement parts cannot generate profit. This is the story of the cheapest metal preservative ever discovered and how the auto industry made you forget it existed. Welcome to Forbidden Home Science. If these stories matter to you, the subscribe button and the bell are the best way to keep this knowledge alive. This is where we open the vaults that the industry locked shut. In 49 BC, Julius Caesar ordered his naval commanders to coat every warship hull with a dark extract pressed from oak bark. The Roman galleys that patrolled the Mediterranean faced an enemy worse than any army: salt water. The wooden keels rotted fast, but the iron fittings corroded faster. Roman blacksmiths discovered that soaking iron bolts and brackets in a concentrated tea made from crushed acacia pods created a blue-black film on the surface. That film resisted salt spray for entire sailing seasons. They did not understand the chemistry, but they understood the result. Ships treated with bark extract lasted 3 to 4 times longer than untreated vessels in the Roman dockyards. The knowledge spread across the ancient world. Egyptian craftsmen soaked metal tools in pomegranate rind solutions before storing them in desert tombs. Archaeologists pulled iron, chisels from those tombs 3,000 years later, and found them still intact under a thin, dark coating. In medieval England, blacksmiths guarded a technique they called bark liquor. They would boil oak galls, the small round growths found on oak branches, into a thick brown concentrate. Every finished blade, every hinge, every iron fitting was dipped in that solution before delivery. A blacksmith in 14th century Sussex could guarantee his ironwork against rust for 20 years. His secret cost him nothing but a bucket of water and a handful of oak galls from the nearest forest. The compound responsible has a name: tannic acid. It belongs to a family of molecules called tannins found in tree bark, tea leaves, grape skins, acorns, and dozens of common plants. When tannic acid contacts iron oxide, which is rust, it triggers a chemical reaction that converts the unstable orange powder into a completely different substance: iron tan, a stable blue-black corrosion-resistant compound that bonds permanently to the metal underneath. It does not sit on the surface like paint. It becomes part of the metal itself. By the 1700s, the British Royal Navy had codified the process. Naval dockyards in Port South and Plymouth kept barrels of tannic solution on hand specifically for treating anchor chains, cannon fittings, and hull reinforcements. A 1789 log book from the Port South dockyard records that iron components treated with oak bark solution showed, quote, "No measurable degradation after 40 months at sea, 40 months of salt water, tropical humidity, and cannon fire for the cost of boiling tree bark in a copper kettle." During the First World War, the British Army coated field equipment with tannic acid solutions manufactured in bulk from South American corral trees, rifles, bayonets, artillery shells, vehicle chassis. Entire tank battalions rolled across the mud of Flanders with tannic-treated undercarriages. By the Second World War, the United States military had adopted the same approach. Technical Manual TM9 Tau 1795, published by the War Department in 1943, explicitly recommended tannic acid solutions for rust conversion on military vehicles and field equipment. The manual described mixing 1 part tannic acid powder with 10 parts water and applying it directly over rusted surfaces with a brush. No prior sanding, no primer. Cost per gallon of solution was less than 15 in 1943. Adjusted for inflation, that is roughly $3.50 cents today. The same military that spent billions on tanks and aircraft was protecting all of it with a $3 liquid anyone could mix in a canteen cup. This video is just the surface. I have collected everything the outdoor industry does not want you to know, all inside the complete Forbidden Home Science Vault: a solar water heater built from scrap that the energy industry tried to bury, an earth battery that generates electricity from dirt, 2 metals, and nothing else, a bioand water filter that purifies river water better than commercial units costing hundreds, an atmospheric water harvester that pulls drinking water from thin air in the desert, a Trump wall heating system that warms a shelter all winter with 0 fuel, food preservation methods using Meyer bags that keep supplies edible for 25 years, rainwater collection blueprints the local code enforcement does not want you to see, and this rust elimination guide that saves thousands in metal repair. Over 10 guides in one place. No fluff, straight to the point. The link is in the description. But stay right here, because the science behind this $3 liquid is where the story gets heavy. In 1986, researchers at the North Carolina State University Department of Material Science published a landmark study on tannic acid conversion coatings. They applied a simple tannic acid wash to steel samples corroded under controlled laboratory conditions. After treatment, they subjected the samples to a 500-hour salt spray test, the industry standard for evaluating corrosion resistance. The tannic acid-treated steel outperformed two commercial rust-inhibiting primers that cost over $40 per quart outperformed them, a solution that costs pennies per application. Beat products sold for $40 at the auto parts store. The study measured adhesion strength using crosshatch tape pull tests. Tannic acid conversion coatings scored a perfect 5 out of 5, the same rating given to factory-applied electrocoat primers on brand-new vehicles rolling off the assembly line. A $3 kitchen mixture matched the corrosion protection of a factory paint system that cost manufacturers $18 per vehicle to apply. Let that settle for a moment. A study published in the Journal of Coatings Technology in 1992 confirmed that tannic acid reacts with iron oxide at a molecular level to form ferric tannic complexes. These complexes are not just a surface coating. They penetrate into the micropores of corroded steel and seal them from the inside out. The researchers measured oxygen permeability through the converted layer. It blocked 97% of atmospheric oxygen from reaching the base metal 97%. That is comparable to hot dip galvanizing, which costs between $2 and $4 per square foot at a professional facility. Tannic acid achieves nearly identical protection at roughly 3 cents per square foot mixed at home. The numbers get worse for the industry. A 2014 meta-analysis from the Indian Institute of Technology reviewed 37 separate corrosion studies conducted across 12 countries over 4 decades. Their conclusion was devastating for every company selling premium rust treatment products. Tannic acid conversion coatings consistently matched or exceeded the performance of commercial phosphate-based rust converters in salt spray resistance, adhesion, and long-term stability. The average commercial rust converter at the hardware store contains between 8 and 15% tannic acid blended with proprietary polymers and solvents. The tannic acid does the converting. The polymers and solvents are there to justify the markup. A 12 Oz bottle of commercial rust converter sells for $14 to $22 at any auto parts counter. The tannic acid inside that bottle costs the manufacturer roughly $40. That is a markup of over 3,000%. Meanwhile, pure tannic acid powder sells online for about $12 per pound. 1 pound mixed with water produces approximately 10 gallons of rust converting solution. 10 gallons is enough to treat every rusted surface on a full-size pickup truck, a set of garden tools, a chain link fence, and a steel storage shed for $12. If you have made it this far, you already know more about rust protection than 99% of vehicle owners. Subscribe and share this with someone who is tired of paying body shops to fix what a $3 bottle could prevent. Everything the industry buried is inside the complete Forbidden Home Science Vault. The link is in the description. Now stay with me because the next vault is the heaviest one yet. So why is this not common knowledge? Why does every mechanic not hand you a bottle of tannic acid instead of a $400 repair estimate? The answer is sitting in the financial reports of the global automotive aftermarket. The automotive rust repair and rust proofing industry generates over $14 billion per year in North America alone, according to the Automotive Aftermarket Suppliers Association. That includes body panel replacements, undercoating services, frame repairs, and rust preventive coatings sold at dealerships. $14 billion flowing through dealership service bays, collision centers, and auto parts retailers every single year. A $3 solution that any vehicle owner could apply in a driveway with a paintbrush threatens that entire revenue stream. Think about what happens when a truck owner in Michigan discovers that tannic acid converts the rust on his wheel wells permanently. He does not book a $600 appointment at the body shop for panels that could have been saved for pennies. He does not buy a $70 can of commercial undercoating. He does not trade in his vehicle 2 years early because the frame is rotting. One customer lost is manageable. 10 million customers lost collapses in industry. The rust protection market depends on one critical condition. You must not know how to do this yourself. The commercial rust converter brands know exactly what tannic acid does because they put it in their own products. but they surround it with proprietary formulas and patented delivery systems to justify retail prices 30 to 50 times higher than the raw ingredient. They cannot patent tannic acid itself because it is a naturally occurring plant compound. You cannot trademark oak bark, and you cannot license a molecule that falls out of a tea bag. So instead, they patent the packaging and they market the mystery. Rust Reformer, Rust Converter Pro, Corosol O. Every one of these products lists phosphoric acid or tannic acid as its primary active ingredient. Everyone charges $15 to $40 for what you could mix at home for pennies. This is not a conspiracy theory. This is a pricing structure designed around your ignorance. And it works because nobody teaches you the alternative. Your grandfather knew. He kept a jar of G solution on his workshop shelf right next to the linseed oil and the turpentine. Every hand tool went through that jar before it went back on the pegboard wall beside the workbench. His wrenches lasted 40 years. Your wrenches last 4 before the chrome peels and the rust eats through. The difference is not the quality of the steel. The difference is the knowledge that was never passed down. Here is what to do. Buy Fuji-grade tannic acid powder from any online chemical supplier or bulk herb retailer. A 1-pound bag costs between $10 and $14 and will last you years. Measure 2 TBSP of tannic acid powder into a clean glass jar. Add 1 cup of warm distilled water from any grocery store. Stir until the powder dissolves completely into a dark amber solution. That is the $3 liquid the auto industry does not want you to know about. To apply it, start by removing any loose or flaking rust with a wire brush or steel wool. You do not need to get down to bare metal because that is the entire point of a rust converter. It works on existing corrosion. Using a cheap foam brush from the hardware store, paint the tannic acid solution directly over the rusted surface. Within 30 minutes, you will see the orange rust begin turning blue-black. That color change is the chemical reaction happening in real time. Iron oxide converting into iron tannate right before your eyes. Allow the first coat to dry for 2 to 4 hours, depending on humidity. Apply a second coat for maximum penetration into deep corrosion pits. After 24 hours, the surface will be a uniform dark charcoal color. That dark layer is your new primer. You can paint directly over it with any oil-based or latex top coat. No additional primer needed. The total cost per application on a truck frame rail is roughly $8. A full vehicle undercarriage treatment uses about 1 quart of solution. Total cost approximately $35. Compare that to a professional rust proofing service that charges $300 to $600 and uses products containing the exact same active ingredient. You're not paying for protection. You're paying for the privilege of not knowing what is in the bottle. This knowledge did not die. It was buried under marketing budgets and dealership service menus. But tannic acid is still sitting in every oak tree and every forest on this continent. It is still dissolved in every cup of black tea you have ever brewed. The Romans knew. The blacksmiths knew. The War Department published it in a field manual 80 years ago. The only people who forgot are the ones the industry needed to keep paying. If this vault opens something for you, subscribe and share this video with every person you know who owns a vehicle, a toolbox, or a piece of metal worth saving. Every share preserves what the rust repair industry tried to erase from public knowledge. Every subscription keeps this channel digging up what they buried beneath $14 billion of annual profit. The next vault opens soon, and what is inside might be the most dangerous secret the outdoor industry has ever hidden. The Forbidden Home Science Vault keeps growing, and the link is in the description before they find a way to shut it.